Visiting the moon involves a complex series of steps and technologies, beginning with preparation on Earth and ending with a safe return. Here's a detailed explanation of what a lunar mission typically entails. 1. Mission planning and design. Objective definition. Define the mission's goals such as scientific research, exploration, or technology demonstration. Spacecraft, design, and build the spacecraft, including the lunar module for landing and the command module for return to Earth. Trajectory planning. Calculate the spacecraft's flight path, taking into account the positions of the Earth, Moon, and any other relevant celestial bodies. 2. Launch preparation. Rocket assembly. Assemble the launch vehicle, typically a heavy-lift rocket like the Saturn V used in the Apollo missions or the Space Launch System, SLS, for the Artemis program. Crew training. Train astronauts in various aspects, including spacecraft operations, lunar surface activities, and emergency procedures. Mission simulations. Conduct simulations to prepare the crew and ground control teams for various scenarios. 3. Launch, countdown, and liftoff. The spacecraft is launched into space atop a powerful rocket, reaching Earth orbit before heading towards the Moon. Trans-lunar injection, TLI, the spacecraft's upper stage fires to propel it out of Earth orbit and toward the Moon. Journey to the Moon. The spacecraft coasts through space, making minor adjustments to its trajectory. Perform any necessary adjustments to ensure the spacecraft is on the correct path. Lunar orbit insertion. The spacecraft fires its engines to slow down and enter lunar orbit. Fine-tune the orbit to prepare for the lunar landing. Lunar landing. The lunar module separates from the command module and begins its descent to the Moon's surface. The module navigates to the pre-selected landing site using thrusters to control its descent and land safely. Lunar surface activities. Extravehicular activities, or EVAs, are when astronauts exit the lunar module to explore, conduct experiments, and collect samples. They also engage in scientific research, deploying instruments and conducting experiments right there on the lunar surface. And of course, they document everything, taking photographs and videos for later analysis and study. Return to lunar orbit. The lunar module's ascent stage lifts off from the Moon's surface to rendezvous with the command module. Then, the ascent stage docks with the command module, and the crew transfers back to the command module. Journey back to Earth. The command module's engines fire for the trans-Earth injection, or TEI, propelling it out of lunar orbit and back toward Earth. After that, the spacecraft coasts back to Earth, making minor adjustments as needed. Now let's talk about re-entry and landing. First, the command module separates from any remaining service modules. This is a crucial step in preparing for re-entry. As the command module re-enters Earth's atmosphere, it is protected by a heat shield. This shield is designed to withstand the extreme temperatures generated during re-entry. Then parachutes deploy to slow the descent. These are essential for ensuring a safe and controlled landing. Finally, the command module lands in the ocean or on land. Recovery teams are on standby to retrieve the astronauts and the spacecraft, bringing them safely back home. Post-mission activities are crucial for the success of any lunar mission. First, the crew recovery process ensures that astronauts are safely retrieved and undergo thorough medical checks. Next, the lunar samples and data collected during the mission are meticulously analyzed in specialized laboratories. Finally, the mission team conducts a detailed debrief to review the mission, learning from both the successes and the challenges encountered. Historical and future lunar missions have always captured our imagination. During the 1960s and 70s, NASA's Apollo program successfully landed humans on the Moon, beginning with Apollo 11 in 1969. Fast forward to today, NASA's Artemis program aims to return humans to the Moon by the mid-2020s, including the first woman and the next man on the lunar surface. There are several challenges and considerations when planning lunar missions. Technical challenges include precise navigation, reliable life support systems, and robust spacecraft design. Health risks are also a major concern, as we must protect astronauts from space radiation, the effects of microgravity, and psychological stress. Additionally, the cost is significant, with high financial investments required for research, development, and execution of these missions. Exploring the moon continues to be a key objective in space exploration. It provides valuable scientific knowledge and lays the groundwork for future missions to Mars and beyond.